Right. So we're still on this introduction to the CDK, or more generally, we're talking about infrastructure as code. And so the last day, I made the argument for that concept of infrastructure as code. And I talked about the evolution of how we got to where we are today, which is essentially writing infrastructure or describing infrastructure using a variety of imperative programming languages. So if I fast forward to roughly here, maybe. So the CDK framework, it's provided by AWS. It was custom made for AWS platform. You can get a more generic version of it now, which works with Microsoft Azure and Google Cloud. It's called CDK Terraform. We're not looking at that though. I'm not certain how that project has progressed, but the CDK one is pretty popular in industry. And so what the CDK allows us to do is, as I said there a moment ago, it allows us to write our infrastructure using an imperative programming language. The alternative prior to the CDK was we had to describe it using a declarative language, typically JSON or YAML, and there were lots of disadvantages with that. Also, what the CDK will do for us is it will take care of managing the state transition of our infrastructure. Now, really, when I say the CDK does that, it's really CloudFormation, which takes care of managing the state transition, because as the image on the left there is indicating, the CDK framework is really leveraging this CloudFormation service provided by AWS. CloudFormation is categorized as a resource provisioning engine. So that's behind the scenes all the time here. Fortunately, we very rarely will need to look at the CloudFormation service, but it's core to what's actually going on behind the scenes. So in the language of the CDK framework, we talk about developing a CDK app, which is comprised of stacks. A stack is comprised of constructs, and a construct then is comprised of resources. So resources is the kind of language of AWS infrastructure, whereas these high-level concepts of stacks and constructs, that's what the CDK allows us to think in terms of. These are abstractions, as we say. These are abstractions on top of what's really happening down at the ground level. At the ground level, it's resources that the AWS cloud understands. And the image there shows the relationship between resources and all of the other constructs, which I talked about the last day. The nice thing about this CDK framework is the sheer volume of code that you have to write to describe your infrastructure is far less than the volume of code we had to write when we were using the kind of declarative infrastructure as code models. In other words, writing JSON and YAML. And that's roughly where I left off the last day. This is kind of describing what's happening kind of at runtime, if you like. If I've developed a CDK app and I want to quote unquote run it, we don't talk about running it, we talk about deploying it. So if we move from left to right, so the developer stroke operations person, they write their infrastructure as a CDK app. That's what this is representing. Now, we are using TypeScript, so that's why I've put TypeScript here, but it supports other languages. So this is representing my CDK app. I then give that to the CDK framework, and what it will do is it will generate a CloudFormation template of that. Okay, so this is typically in YAML. That CloudFormation template then is what the CloudFormation service understands. And so the CloudFormation service takes that template, which is just a big, long, unwieldy document written in YAML or JSON, and it interprets it, and it essentially makes SDK calls. When I talk about the SDK now, the SDK in your language was Boto3 last year when you were writing Python scripts and you were using the Boto3 library. Boto is essentially a Python implementation of the SDK, of the AWS SDK. And so CloudFormation, I don't know if it's using Boto underneath the hood or not, but it's using some SDK, which is talking to the various AWS services. And those AWS services then, EC2, S3, IAM, et cetera, they go away and create the actual resources. So that's the kind of flow that happens every time you execute your app or run your app. But again, as I say, we don't talk about running a CDK app. We use the language of deploying a CDK app. So strictly speaking, this is the flow that occurs when we deploy an app. And the same applies when we want to change the app. So if I go along and make changes to my code here now, in other words, I'm making some configuration changes to my infrastructure, I may be adding some infrastructure, reconfiguring existing stuff, getting rid of stuff, et cetera, but I'm just changing code. That code then is yet again given to the framework. The framework generates a completely new CloudFormation template. It gives that template to the CloudFormation service, and the CloudFormation service will compute the changes that have happened since the previous deployment. It computes that, which is pretty heavyweight stuff, and determines from that computation what SDK calls it needs to make to which services in order to request changes to particular resources. That's this whole state management side of things that I talked about last week and mentioned at the beginning of this lecture. All that state management is really taken care of by CloudFormation. We just go along and make simple changes to code, but those changes have to be computed into state changes to your infrastructure. So once you've installed the framework on your local machine, and the installation is simply, it comes in the form of an node package. So it's an NPM installation, which you will do in next week's lab. So I've installed, let's say, the CDK framework on my local machine. And this is the kind of sequence of commands that you tend to execute from the command line. So CDK init, you're telling us what are you creating here? There are two things that you can create with the CDK framework. You can create an app, or you can create a construct. We won't be creating any constructs. We'll be just creating apps. You tell it what language you're going to be using. And so, you know, there are, as I said, a wide variety. So it's going to be one of these. It's going to be TypeScript in our case. Hit return, and then that essentially is going to scaffold a folder structure for you and put some boilerplate code into your app. You then go along and make changes and add code to your app. This step here is optional, right? The CDK sent, when you run that, you obviously run this command from the base folder of the app that you created up here, or the project that you created up here. Sent is short for synthesize, and essentially that's the verb that we use when we talk about transforming our imperative code into declarative code, i.e. transforming our TypeScript into CloudFormation YAML. we're synthesizing. That's the term that we use. So if you execute that command, then what you will get on your desktop machine is an actual copy of the CloudFormation template. We don't really need to do that, and I don't ever do this, but you can if you did want to actually look at the CloudFormation YAML that's generated from your TypeScript code. Very experienced engineers would actually do that if they wanted to see what is the actual low-level YAML that's generated. CDK deploy, then, that's essentially the run. That's what I was describing on the previous screen there. So a command as simple as that triggers, if I go back, I'm allowed to go back, that kind of triggers this whole flow here. And so at the end, you'll get a response back telling you that your stack has been deployed or it has failed. Okay, so let's suppose this is the first time that we've done it. We're now essentially deploying a new app to our, we're deploying a new app, new set of infrastructure. And let's suppose it worked fine. Then we go along, let's say we want to make some changes to our source code. We're changing our infrastructure. This time when we go CDK deploy, what we're now doing is we're triggering a state change, but it's the same command whether you're deploying for the first time or you're making updates. The CDK framework and CloudFormation will take care of all the heavy lifting for you, as I was describing in the previous screen. Eventually, you may want to actually tear down all the infrastructure. And so the command is simply CDK destroy, and that sends a request up to the CloudFormation service telling it tear down all of the infrastructure that you created for this particular app. And so what's really nice about CloudFormation is that, this is something that I would do even though I know I'm going to be working on the app maybe the following day or a couple of days later. Just tear it down. Don't leave the infrastructure up there in the cloud, just in case you're incurring any costs. Because the next time you come to work on this project, the first thing that you do is just CDK deploy. And you're essentially kind of starting all over again. You're just deploying a new app up into the cloud. So anyway, that's the kind of the workflow. Now, if I come back to this command here, when we go CDK init, this is the folder structure. This is the kind of default folder structure that the framework creates for you. And so there are really two files, although in fact there's only one file that you will spend 99% of your time editing, and it's this one here. But if we take it from the top, so there's a bin folder, and the file inside in that folder, the name tends to be the same as the name of the actual parent folder itself, but you can change it if you want to, but there's no need to. So in and these are all TypeScript files in my case, because I asked it to create a TypeScript CDK app for me. What this file is referred to as on the left here, I'm saying it's the entry point for the framework itself. So when we run the CDK deploy command, for example, what the framework actually does is it goes looking for this file. And the code inside this file tells it what stacks make up your app. We'll look at the contents of it in a moment, but there's only really a couple of lines of code typically in this file. The real business is going on in the lib folder. In the lib folder, you have one file per stack of your app. Now, in our case, I don't think we'll ever go beyond having one stack in an app. So this is essentially our stack file. And it's in there, it's where we put our infrastructure code written in TypeScript. You can see here like that testing your infrastructure is something that's very possible with the CDK. It was very difficult back in the earlier days of infrastructure as code. We won't go near testing though. We just don't have time for it. And some of the rest of them are just some of your standard stuff, your git ignore, etc., etc. There's a tsconfig file, which is a TypeScript configuration file at the bottom there, but we rarely need to go near that. And the usual stuff, package.json, which we're familiar with. So this is the entry point. This file here is the entry point. Inside that file is where we explain in TypeScript what stacks make up our app. And then here is where we put the stack description itself using TypeScript. Now, if I just go back a few slides to here, okay, to here, sorry. I said that an app is comprised of stack and a stack is comprised of constructs, okay? So it turns out that there are 3 types of constructs from CDK's point of view. This is how they've modeled it. And so if I go forward now again, there are 3 types of constructs: L1 constructs, L2 constructs, and L3 constructs. Now, 99% of the code that we will be writing in this module will be concerned with L2 constructs. But take it from the top. You see, AWS is always adding new resources to its suite of resources, as you know. And so the CloudFormation framework itself lags behind the most current resources that might be available to us. But you may still, as a CDK developer, you may still want to avail of the newest AWS service. Sorry, did I say resource there? I should have said service. AWS are always adding new services to their suite of services. But the CDK is kind of lagging behind a little bit. No, not by much, admittedly, but like we're talking about months maybe, or at most. But if you did actually want to use the most recent service that's provided by AWS and you wanted to use it within your CDK app, then you can actually still do it, because you can use what's called an L1 construct to avail of it, because an L1 construct, as it turns out, is essentially the exact same as writing CloudFormation directly. Okay. So what we say is that an L1 construct, it's essentially a CloudFormation resource. You're down at the very lowest level. There's a one-to-one relationship between an L1 construct and a CloudFormation resource. So there's no abstractions, there's no sensible default values for configuration settings and all that kind of stuff. We very rarely need to, in our case anyway. L2 constructs, on the other hand, an L2 construct, okay, the name is AWS construct, but that doesn't really mean anything. What an L2 construct is a construct which, when it's converted into CloudFormation, it generates many CloudFormation resources. So one L2 construct does often create many resources down at the lowest level, down at the kind of infrastructure level. And that's the whole point really of the CDK. You've got these abstractions available to you, so you don't have to write as much code as you did back in the days of writing CloudFormation templates. So there's one-to-many relationship with the CloudFormation resources. When I talk about CF there, I'm talking about CloudFormation. When I talk about CloudFormation resources, these are the actual kind of entities, if you like, down at the infrastructure level. Lots of default values, so we don't have to write as much code as we do if we were coding up an L2 construct. High level of abstraction. L3 constructs then are just a level higher yet again. An L3 construct generates, it's really kind of pattern-based stuff. So you might have, for example, an L3 construct which produces an EC2 instance managed by an auto scaling group and an application load balancer in front of it. All of those resources and all of the other things that go with that architecture, all of that might be wrapped inside an L3 construct. We won't be using any L3 constructs, but you'll come across these terms L1, L2, L3 if you read about CDK anywhere. Right, that's a lot of talk though. Can I actually show you something? So I have created a folder, which is this one here, CDK demo. So I created that folder, and then I went into that folder, CD down into it, and I ran CDK init. I told it it's an app I want to create, and I want to use TypeScript. And when I did that, it went away and created the folder structure that I showed you there a moment ago, which is here. So this is as I was talking about. And so, as I said, the main action is going on here. So this app of mine is just comprised of one stack. So if we look inside this file, it's a TypeScript file. Just some regular imports at the top, importing the CDK itself, the CDK lib, and this is the construct library that I was talking about. Well, I wasn't talking about it, but I was talking about constructs. So constructs are kind of high-level abstractions, and they're implemented as classes, abstract classes, because usually we extend them in order to create custom constructs. We won't be creating any custom constructs. We will be using constructs, L2 constructs that are provided by the framework itself, but you can implement your own constructs. And because this particular stack is going to be generating an EC2 instance, I'm also importing the EC2 SDK for TypeScript. That's kind of essentially what this is here. Okay, sorry, beg your pardon. It's the CDK part of the EC2 part of the CDK framework that I'm availing of here. Okay, so how do I implement the stack? Well, a stack turns out, as we can see here, to be implemented as a class, as a TypeScript class that extends the stack class. This stack class is defined in the library up here. Okay. And here's my constructor. Now it turns out that when you implement a stack, really it's only the constructor that you put any code into. We don't have lots of methods. You can have, but they're all going to be private. The main method, if you like, of a CDK stack class is the actual constructor. And that's where we put all our infrastructure code. So here's our constructor. Now I know we haven't actually written any TypeScript classes in the labs. It was all functions we were doing. But the reason I decided not to do that is because I think this TypeScript class syntax is pretty straightforward if you've done any classes in any other language. So that's my rationale there. So the constructor, anyway, for a TypeScript class is called constructor. And here's the implementation of my constructor. The constructor takes a number. So if you want to create an instance of this stack, and we do that up here in this file, maybe if I just flip over to that. This is the file where you, what do you do here? You create an actual app itself. And then I'm creating a stack. This is actually my stack that I've defined in the other file. I'm creating an instance of it. And I'm passing to the constructor. These are arguments I'm passing to the constructor. I'm passing the actual app itself, which I just created here. Every construct that you create in the CDK, you've got to indicate what does that construct belong to. And so in this case, I'm creating an instance of a stack, and the first argument is telling the CDK framework that this stack belongs to or is contained within this app, which makes sense, right? Because my app is comprised of stacks. The other arguments to my stack is, this is just a name for the stack. It's an arbitrary string. And these are some additional properties that I'm passing to my stack. Invariably, the most you would need to tell it is what account are you going to be deploying it to. Now, probably not good practice to put an actual, this is my AWS account ID, and I'm actually hard coding it in there, which isn't great programming, admittedly, but just ignore that. And I'm also telling it what region I'm going to be deploying this to over here. That's all that's in this entry point script. Create an app and then add your stacks to that app. And there's only one in my case. Let's go back to my stack though, which is, so what am I doing inside in this stack? And the main entry is, if I collapse that there, you could nearly work out maybe what I'm trying to do here. It looks like I'm creating an EC2 instance. And I am associating that instance. I have to, this is an example now, sorry, this is an example of an L2 construct. But I'm creating an EC2 instance. And the first argument, I have to tell it, what do I want this construct to be contained within? And I'm saying it's contained within this. This is referring to the instance of the stack that's being created, the other file. So for every entity that you create, you have to associate it with an existing entity, and so on. This, and it's always this anyway. But technically, what I'm saying is, I want to create a new EC2 instance, and I want it to be part of this stack. The next argument, sorry, wrong one, sorry. The next argument is just an identifier for this resource. Okay, to use that language. And my resource is an EC2 instance. That's an identifier that I want to have for it. And the rest then is essentially how you want the resource to be configured. Now, because it's an EC2 instance, the configurations are obviously specific to that type of resource. And again, I would argue we could probably work out-ish anyway, what I'm trying to get across here. What type of EC2 instance do you want? It looks like something like a micro, i.e. a T2 micro. That's what I'm trying to create here. All of these, these things these are all properties or variables that are declared in the library that I'm importing on top there, because you can see I'm always going EC2.something.something. EC2 is referring to, this import, the AWS CDK EC2 part of the framework. But I am creating an EC2 instance. I want it to be a T2 micro. a burstable EC2 micro. In addition, it looks like here I'm talking about the architecture associate that I want. In this case, what am I looking for? An Amazon Linux 2 OS for my EC2 instance. So either way, or in general, right, what I'm doing here is I'm describing the configuration settings that I want from my EC2 instance. The one I skipped was this one here, which is what VPC do I want my EC2 instance to run inside? And this line here, it's a bit complicated now, but essentially what that line is doing is it's asking the CloudFormation is getting a reference to, or sorry, we're trying to get a reference to the default VPC of the account that this app is going to be deployed to, or this stack is going to be deployed to. That's essentially what's going on there. I wouldn't be too worried about it, because for the rest of this module, with the exception of today and next week's lab, we won't be doing anything related to EC2. So I don't want to over describe this kind of stuff, because we'll be moving on from it anyway. But that's essentially what I'm doing here. That piece of code, the effect of it is to get a reference to the VPC, the default VPC of the account, AWS account and region that this stack is going to be deployed to. And then associating I'm hosting my EC2 instance within that VPC. And that's it. That's so far, that's all I'm doing. Now, clearly, you'd have to look up the documentation on EC2 to find out what are the various properties that you can configure here. Yeah. And I'm not going to spend a whole lot of time on that, because we're not going to be doing a whole lot with EC2. So that's my infrastructure. I've got some other stuff down here, but I've commented it out for the moment, and I'll bring it in. So if I just deploy that, I want to deploy this app. My app is consisting of just one stack, this stack here. That stack is trying to create one EC2 instance with this particular configuration, and it's going to be contained within the default VPC of the account that it's being deployed to. So if I flip over to my account, okay, so I've already logged into my AWS account, and if I go to, let's say, the EC2 service, I can see here that there are no running instances at the moment. And the only reason this one is here, but you can see it's terminated. I was just running, I essentially ran the stack that I've just shown you there, or the app that I've shown you. I just ran it there earlier this morning, and then I destroyed it. So this is just hanging around, but it's in a terminated state, so it's not important. I'll just do a refresh to see if that actually goes away. No, it's okay, doesn't matter, it's still there, but it's terminated. So let's deploy this stack. And so the command is just CDK deploy. So when I hit run now, the CDK framework goes to this file, finds out what's the app comprised of. Then it gobbles up the stack code itself. It does an examination of it, generates the CloudFormation template, does some basic analysis of it, and it's telling you here about certain IAM roles and security groups that you're creating. Are you happy with that? So we'll just say yes. And now it's going to upload the CloudFormation template that it has created, upload it to the CloudFormation service itself. And the CloudFormation service will essentially execute the template. And so we're getting confirmation here. There's kind of communication between CloudFormation service and my local machine telling me, updating me on the progress of the provisioning of the infrastructure. Now, because it's an EC2 instance that's being provisioned, that typically takes a little bit more time than if you were deploying a serverless infrastructure, which is what we're going to spend the majority of our time doing, as it turns out. Just as it's working its way there, if I switch over to the CloudFormation service, this is listing all of the stacks. CloudFormation doesn't talk in terms of apps as such. That's a kind of a CDK thing. It deals with stacks, and because our app just comprises of one stack, there should be a stack here corresponding to the stack in my app, and it is this one here. And if we selected it, and I'm not sure, you probably haven't used CloudFormation, and I don't really need you to be that au fait with it, other than the basics, checking to see is your app up there. Sorry, now there's just things popping up on my site here, but if I go into it, you can, if you click on events here, you can get updates on the progress of the deployment of your stack if it's currently ongoing. And it looks like, okay, it looks like it's finished actually. Oh no, sorry, creation in progress. So it's still working its way through creating the various resources. Now, in my code, I just had one resource, one resource, an EC2 instance. But when that gets converted into CloudFormation, it actually generates a couple of resources like a security group, an IAM role, and one or two other low-level resources as well. So there's a couple of steps that have to be carried out in the cloud, if you like, before my stack is completely deployed. So it seems to be working its way through. Is it still? Yeah, it's slow enough actually. But what I let's go back to EC2 because that's where we're more interested in. We can see my second instance is, okay, so it's up and running actually. Yeah, and my command is finished, and I got back a successful result. So that's fine. My EC2 instance is now up there. I'm not really interested in, SSHing to it or anything like that, or there's nothing really useful running inside in it. But if I just take a quick look at, if I just select it, and for example, if we select the security and look at the security group associated with this instance, not surprisingly, we can see, there are no inbound rules, and there is probably an outbound rule, all right. it allows all outbound traffic, but by default, there's no inbound traffic. So we can't really do anything with this EC2 instance. So let's supposing I want to open up the SSH port 22, for this EC2 instance, or to use the language of infrastructure as code and CloudFormation, I want to change the state of my stack, and in particular, change some part of the EC2's configuration. So I go back to my code, and that's what I have down here, just as a convenience for myself. So I'm going to uncomment this. And I'll actually move it above the, usually it doesn't, usually you don't have to be too concerned about the sequencing of the code in your construct, unless there's one variable that's referring to another variable. And if that's the case, then the variable being referred to has to appear sequentially before the one that's doing the referring. And that's going to be the case in this case, because my EC2 instance is going to be referring to the security group that I'm creating with the code that I've just highlighted there. So I'm just going to move that up. But again, just to have a look at it, look, I'm creating something new. It's another construct. In this case, I'm using the security group construct, which is contained within the EC2 package. My EC2 package is this one here. And yes, you'd have to look up the documentation on it to know how to use it. But so it's another construct. I have to associate this construct with its kind of container. And the container, again, is this. This is referring to the actual stack itself. That makes sense. That's just an identifier, a text kind of identifier, a human readable identifier that I want to give this construct, which is clearly a security group construct. And then here are some properties that I want to set for this construct. And again, the properties depends on the construct itself. In the case of a security group, you also have to associate it with a VPC. Now, this is TypeScript, by the way, not surprisingly. VPC is a mandatory property that you have to set, as opposed to an optional property. There are lots of optional ones as well. But anyway, VPC, I'm associating my security group with the same VPC that I have kind of declared up here. And as you might kind of work out, this is setting the outbound properties of the security group. That's fine. So that's just a simple, essentially that security group there is essentially the same that's currently associated with the EC2 instance. So there's no gains there, but here I'm taking my security group and I'm adding an ingress rule to it. And I'm essentially opening up port 22. Again, as I say, you could kind of work out what I'm doing here. I'm opening up port 22 for any IPv4 address. And that's just a description of it. And I'm associating this inbound rule with the security group that I've just created here. Now what I need to do is I need to link this security group with my EC2 instance. And so thanks to the kind of hinting and intelligence associated with TypeScript, if I start typing now, it's hinting to me, maybe this is the property that you want to set. And you can see the question mark at the end. So it's an optional property. So that's why I didn't have anything there initially, but now I want to set it to something specific. So I'm going to select that. and I'm going to set it to, what did I call it? Server. So I've made that change and no errors. And I'm going to do a redeploy. And it doesn't work, of course. Let's see what it doesn't like. This is a VS Code thing now. I sense more so than a. Oh yeah, okay. It's working this time. Um, on very rare occasions, not so much the error that I just saw there now, but on very rare occasions, when you do CDK deploy, you get back an error straight away. Usually, a segmentation error is what it calls it. I haven't, like, it might happen once in 100 deployments, and because you see there's so much network communication going on, when I hit yes here, or even when I do CDK deploy and hit return, there is actually a lot of network communication going on between your machine and the AWS itself. And so with any network communication, things can go awry on rare occasions. And I'm not sure if that's the explanation for why it complained about unreachable code there a moment ago, and there was nothing clearly wrong with the code. But anyway, we'll plow on. Just cut it out of the video. Isn't that the solution? So it's now going through its recreation of the CDK template, sorry, the CloudFormation template, sending it up to CloudFormation. CloudFormation already has a version of the stack up there, as we saw. So now it knows what it needs to do is a diff operation between the new template that it received for that stack and the one that it has already, and does a comparison and makes the relevant SDK calls to, in this case, it would make the calls to, I guess, the EC2 service to create a new security group, etc., etc. So let's see, did it actually work? So I'll go back to my instances. I'll just do a refresh. You can see the terminated one has disappeared now. Security groups. Yeah, so you can see it's added the port 22 to the configuration. So that's adding something to my infrastructure. If I go back and I decide I want to remove some part of the configuration, some part of the infrastructure. So if I get rid of all of this again, and redeploy, that's that same error, I'd say, is it? Let's see. I'm just going to go on. Good. And here it's updates now. that it's performing. Whereas when I deployed it the first time, it was all creation in progress, and it was creating individual resources. That's done. And back again. Now it's a new security group, really. I'd say that it has created and gotten rid of the old one. So kind of have to do refreshes too. So it's not caching any of these pages. Okay, looks good. It's gone again. Right, so that's our first illustration of A of infrastructure is code, which was all of this stuff here, written in TypeScript. So again, in terms of programming constructs, a stack is implemented as a class. The class has to extend the stack class, which is defined by the framework. The constructor is really the only part of the class that you have to implement. The constructor's parameters, first parameter is the scope that you want to associate with this. A stack, when I talk about construct, a stack is essentially a construct as well. Everything is a construct. So if we looked at the implementation of stack, we would see that that extends the construct abstract class. So we can see here that's the first parameter of the constructor is an object of type construct. And indeed, an app is a construct as well. An app is a construct, a stack is a construct in the sense of the TypeScript implementation of the CDK framework. It's unfortunate now that we're using construct kind of in two different meanings, but so the scope here is, what is the scope of this class, this stack in this place, and its scope will be the app that is contained within. An identifier, which is just an arbitrary string, that kind of human readable string, and the third parameter is props, which is optional. And I think I did pass, if I go back to here where I'm defining the app, here's where I instantiate my stack, and I'm telling it the scope of this stack is app, which is my app instance. That's the identifier that I've decided for it. And here are the properties that I want to pass into the stack. And then in your infrastructure code, you're creating instances of an L2 construct or an L1 construct, or possibly an L3 construct. In our case, this is an example of an L2 construct. And every construct has to be given a scope. We want to associate this EC2 instance with the stack. Every construct needs some sort of an identifier, and then every construct usually has some properties that are mandatory. And in the case of an EC2 instance, here are some of the properties that we need to set. And some of them are optional, as we saw with the security group. And so, you just have more and more L2 or L1 or L3 construct instances created inside in this constructor for your stack. That's the kind of mechanics of it. And then I showed you the deployment. Finally, and really extremely importantly, I have got an EC2 instance up and running there, and even though it's doing nothing, it's costing. So how do I tear down my my app or clean it all up, have it all deleted? Well, it's simply CDK destroy. And in rare occasions, if that fails, if you get back an error when you try and do a CDK destroy, then what you should do is actually go into the CloudFormation service itself. It can happen sometimes that the CDK framework can't delete the app for whatever reason. And so what you do in that case is you just kind of go into the CloudFormation service and delete them at that level. So the way you would do it is you'd select it and hit delete. But in most cases, it will work, and it certainly will work in this case. Famous last words. Confirmation. And again, CloudFormation is communicating and updating our local machine here as to the progress of the tearing down of the infrastructure. And as I would have mentioned there, what's really nice about the CDK is, let's supposing a half hour later, I decide, all right, there's something else I want to play around with for this particular app, then it's just a case of CDK deploy, hit return, and it creates a new instance of your app up in the cloud all over again. And, it takes a matter of seconds. So looks like that worked okay. And can I get confirmation if I go back to here and if I do a refresh? Okay, so the stack is now gone. This, as I said, this is at the stack level rather than the app level, but that's fine. Okay. Now, what you're going to do in this week's lab is, or sorry, next week's lab is the following. You can't see this now, but what you'll be doing is deploying an app that provisions this infrastructure here, and it's a very sophisticated infrastructure. It's comprised of an EC2 instance that's going to be managed by an auto scaling group. There's going to be an application load balancer in front of the auto scaling group, and there's going to be an internet gateway and a NAT gateway as well provisioned for us. Both of the NAT gateway is an expensive resource, so we're going to make sure that we tear down, clean up our infrastructure when we have it created successfully. The EC2 instance is going to be running essentially the Movies web API that he developed in last year's web app dev module. And I'm providing the source code for that in a GitHub repo. So when the EC2 instance boots up, there is some user data. You might remember from last year, user data is boot script that you can associate with an EC2 instance. And what the user data for the EC2 instance is going to do is it's going to clone this GitHub repo, and it's going to run the Movies web API locally and sorry, this is the GitHub repo. Sorry, this is the GitHub repo. It's going to clone that. It's going to build and run the web API on top of the Node platform. I've also set up a MongoDB database running on a server, and the web API is going to be communicating with that. And so you'll be able to send HTTP GET requests to the application load balancer, which will route it to the EC2 instance, which will route it to the web API. And invariably, the request is going to make a request to the database to get some data, list of movies, and send them all the way back, and then display the movies just as a JSON object back in your terminal. Okay, so there's an awful lot going on there. Now, don't be too concerned about all this cloning from GitHub and talking to, that's not really what we're interested in. All we're interested in is this idea that I can create this infrastructure using the CDK framework, and I'm giving you the code, and you can just glance over it. As I've said on a number of occasions, we won't be doing anything with EC2 after this lab, but the only reason I brought it into this lab is because you're familiar with EC2 from last year. You're not familiar with lambdas and serverless and all that kind of stuff. That's going to come from next week on. I'm going to talk about that aspect of distributed systems. So that's what you're going to provision, and you'll see that it actually works when you make GET requests to it. However, before you can use the CDK framework at all, like I was typing CDK commands there at the command line, but you have to, first of all, install the CDK framework. That's straightforward enough. It's just an npm install on your local machine. And so where do I talk about this? Yeah, so that's essentially how you install the CDK framework locally. So it's an npm install. You install it globally, so you can use the CDK command from anywhere. That's just confirmed that it installed properly for you. What you also have to do is you have to, you have to bootstrap your CloudFormation service. And how do you do that? Well, first of all, you have to find out what is your AWS account number. You can do that using the AWS CLI, or alternatively, just go hop over to your console and you get your account API, as you probably already know. Here, this is what I mean by your account ID. So whichever way you can get it, you need to get that. And you then need to run this command. And what this command does is it bootstraps your cloud. It bootstraps your AWS account. Now, what does that mean? What it means is it actually deploys a stack called the CDK Bootstrap stack that has to be present in your AWS account for any of the CDK stuff that I was doing there a while back. This Bootstrap stack has to be present in your account for any of this CDK stuff to work. And if I go back to my AWS account, and if I go to CloudFormation, here we are. You see this stack here, CDK Toolkit? That is the stack that's deployed when we bootstrap our AWS account. And that stack has to be present. So you never delete that. If you do, then you have to just bootstrap again. This stack creates a number of resources in your account. all of which you just don't need to worry about. But for example, it creates an S3 bucket. It creates some IAM roles and some other resources as well. And all of those resources have to be present in your account for all of this CDK stuff to work. So that's the first step that you'll be doing in next week's lab. Now, we may have issues getting everybody up and running, but until we do that, then we can't make any progress with the CDK framework. And so I described there how you go through that. It's pretty straightforward at one level. Now, I've been talking to you during the week and last week about setting up AWS Academy accounts as an alternative to using your personal AWS accounts. Now, unfortunately, it turns out, because I've played around with the Academy there during the week and created I got an Academy AWS account, and I tried to deploy some stacks to it, and it doesn't work. In particular, what doesn't work is this step here. I can't actually successfully bootstrap, and I was talking to Richard Frisby as well about it, and he was doing some good work on it for me. But we couldn't successfully complete the bootstrapping step, essentially because the Academy accounts that we get are too restrictive. So you're going to have to use your own personal accounts for this module. Now, I'm not too concerned about incurring costs, because everything that we're going to be doing is based on this serverless architecture. We're not going to be using EC2 at all. And EC2 is where a lot of costs are incurred by people when they're using the cloud. So we're going to be using serverless. So I'm pretty confident that the costs are going to be very minimal to us, but we're going to have to keep an eye on it, obviously. And what's going to be very important for you to remember is that you destroy any stacks that you create once you're not using them. So if you're working your way through a lab and the lab involves deploying a stack, and you're halfway through the lab, but you haven't finished it, you're going to come back to it in a couple of days' time, maybe, then whatever you've deployed so far, you should just CDK destroy it. And when you come back to work on the lab again, the first thing you do is CDK deploy, and you pick up the story wherever you left off in the lab. And so that's something that you're going to have to remember. Now, sure, initially you forget it and you leave a stack deployed without tearing it down, even though you're not using it. Again, because it's going to be a serverless stack, it's not going to be incurring significant costs at all. The only exception is this EC2 stack that you're going to be deploying next week. We have to be very careful not to leave that up and running. Now, okay, look, I'm talking about maybe $10 is what you might incur if you leave it up there for a week without tearing it down, but it's $10 or whatever. So you're going to be using your personal AWS accounts. And what I would like people to do is to create an IAM user within your personal account and use that IAM user as the main access point for anything that you're going to deploy. So what does he mean by that? So what I'm showing you here now is I've logged into my AWS account, but I've logged in as the root user, which now some of you may be very familiar with IAM users and setting up IAM users, and that's fine. So the rest of this lecture is probably not going to be of much interest to you because you already know all of this stuff. But in particular, the people that are doing the cloud stream would be pretty au fait with this. But for the rest who probably haven't done anything with AWS since the DevOps module last year, this stuff may be a little bit hazy in your memory. So here I am, I've logged into my AWS account, but I've logged in as the root user. And I'm sure the guys would have said to you last year, you should do as little as possible as the root user. Any work that you want to do on AWS, you should do it as an IAM user rather than the root user. So how do I create an IAM user for my AWS account? So what you do is you go into the IAM service and you select users. You can see here, I've created a user called Dermot, and that's the user that I was using for all the CDK stuff that I was demonstrating to you there a few moments ago. So let's suppose you don't have any users at the moment. So we'll go and create user. And we'll call it, let's call it CDK user. And I'm want to select that because I want to provide CLI access for this user. Now, in terms of how to set up the user, even though this is the recommended way, don't select that, select this one instead. We want to be able to create the IAM user ourselves rather than getting this identity center to do it for us. So make sure you select that. I won't take the automated password. Let's say I choose the password for this user ourselves. So what I want now is this user to be able to log in over the management console. Yeah, and give this user a password. I'm just going to use this service here, this generate password service, to generate a password for me. Or you can give it your own password if you want to. That's my password. Clearly, I'm going to destroy this user after this lecture. So, and I'll just put that in here in case I need to remember it. It's okay. And I untick that because if I leave that ticked, it means the first time that the user logs into the console, they're going to have to come up with another password. So we'll untick that. I think that looks good. Now, in terms of permissions, and this is the real reason why we can't use the Academy account for any of this CDK stuff. It doesn't have sufficient permissions. So for this IAM user that I'm creating, I want to give it essentially administrator privileges. I'm not going to add them to a user group, although that is best practice. I'll just assign the privileges directly. And the one you should select is this administrator. There are a couple of administrator access policies, but select the first one. Which is this guy. Okay, that's I think all you really need. So do I need to tick something else? No. right, and create. Now it generates a URL that you can use to log in, which is what's here. Don't worry about the first part. The first part of the URL contains an alias for your AWS account ID. What you will see here is your AWS account ID is the first part of this URL, but I happen to have created an alias for my account ID just because the alias, like all aliases, are easier to remember. But well, maybe I'll come back to this notion of aliases if you want to set it up. So anyway, it's given me this URL that I can use to log in. And what else? Copy, that's okay. So maybe I could actually just take that. Oh, sorry. Why am I doing that? Can I just copy? Now, as you may know, you cannot have more than one AWS Management Console login in your browser at a time. Now, you may or may not have noticed that what I'm running here is I'm running the Chrome in the incognito Chrome window, okay, which I opened up earlier on. So I have a second Chrome window opened. And if I switch over to that, alternatively, you just open up a different browser, Firefox or whatever, and you log in as this IAM user in that other browser. You can't be logged in to more than one account within one browser window. But I have two browser windows. I have two Chrome browser windows open, this incognito one and this kind of ordinary one, let's call it. So let's log in to my IAM user that I just created. But before I do that, I've got to log out of this one, the other IAM user. And I'm going to paste in the URL that I just copied there a moment ago. CDK user, so we call this CDK user. Password. How you know you're logged in as an IAM user as opposed to the root user. If you look at the top right here, it has the IAM username as the entity that's logged in. Whereas in the case when I logged in as my using the root account, it actually is showing my full name. Okay, so I can log in to the web browser as an IAM user, but I actually want to be able to use the CDK framework from and the AWS CLI from my desktop. So in order to do that, I have to create access keys for this user. And so to do that, I go back to my root account login and so here's my new user. And if I go into it and select the credentials part and scroll down to the access keys, select create access keys. So let's do that. and select command line accesses. What do you want these access keys for, as opposed to the other ones? Get it to, do I need to select anything else? I need to select that. And don't need a description as such, so I can get it to create them. So it's created this access key, and it also has created a matching secret key, and you should definitely download those. Is it giving me the option to download them? Yep. So if you select download, there's quite a lot of steps involved here, admittedly, but oops, that's okay. I go to my downloads. Or is it in desktop? There it is there. Now, what do I do with those? You need to configure your local AWS installation. So you already have installed the AWS CLI locally on your machine. You need to configure that with these credentials and also with the IAM user that you just created and that person's password. Where does all that go? Well, if you go to your home folder, so in my case, that's going to be, if I just do CD, then there's a folder called .aws. Okay, that's a folder on my account, and there will be a .aws folder in your home folder of your machine. And there are two files called config and credentials. Now, what I've done is, rather than showing you these files that are private to me, what I've done is I've created fake versions of those two files, and we need to make edits to those two files for this new IAM user that we've created. Otherwise, we won't be able to use the CDK framework, or indeed, you wouldn't be able to use the AWS CLI to communicate with the AWS services. So what do these two files look like, and how do I edit them? What I've done is the following. It's not that I don't suspect Yino would hack my stuff, but this video is going up online, so that means it's available to others. So there was a config and there was a credentials file. So if I open up, I've got a, here, I've got a config fake file. So this is what it looks like. So what this contains, let's look at the other one actually. The other one is more interesting. So this is the credentials file. And the credentials file, you've got to put in what are called profiles in there. And a profile consists of an AWS access key and an AWS secret access key. These two keys are what you downloaded in the CSV file that I downloaded there a few moments ago. and I showed you the CSV file. Here's an example of what the CSV file would look like. Even though it's a CSV file, I'm opening it up here. I'm opening it up in text. Maybe I should open it up in as an Excel, to be more legible. Now, what did I call it? Yeah, this one here. This one, yeah. This is the CSV file that you have downloaded, Maria, that contains your access key credentials. Okay, so am I looking at the right one? I'm not. Let's try again. Maybe it's the one with the name access key in it. So here's the access key. And here's the secret key. So you take those two values and you paste them in here and here. Now, what's default here? This entire thing is called a profile, and you can have a number of AWS profiles. You see, you may have a number of IAM user accounts that you use for whatever reason. And so that means that for each IAM user account that you have, you've got a different set of access keys and secret access key combinations. And each combination is referred to as a profile. You can nominate one of your profiles as your default profile. But you can have other profiles. So let's supposing this default profile that I have here is for another IAM user that I use, but I've just set up the CDK user and I want to create a profile for that user so that I can use that those AWS credentials for that user when I'm doing my CDK development, for example. So what you need to do is essentially make a copy of this. I'm going to give this profile a different name. You can give it any name you want to, but I'm just going to give it the same name as the IAM user that I created. So I call it CDK user. And you'd set these two keys appropriate for that user. So now in my AWS credentials file, I have two profiles. When I'm doing any AWS stuff from the command line, like using the AWS CLI, or when I'm issuing my CDK commands, I can tell the CDK framework which profile should it use, which set of credentials should it use. Because every time I issue a CDK command, there is communication going on between my local machine and the AWS cloud. And the AWS wants to make sure that it's, legitimate requests that are coming in. So these actual credentials are being sent along with all of the communication that's going on between my local machine and the AWS cloud behind the scenes. Now, when I was demonstrating the CDK framework there, I wasn't using any profile. I just did CDK space deploy. In that case, what the CDK did is it went and found the default set of credentials in my credentials file in my .aws folder, and it used those. And that was fine because these default credentials, in my case, are the credentials associated with the IAM user called Diarmid that I showed you there in my account. I'll just go back. Yeah, this user here. Any CDK work that I do is through, if you like, through this IAM user, as opposed to my root user set of credentials. So I have two IAM users. Therefore, in my credentials file on my local machine, I have two profiles, and I've nominated one of them as the default. So let's supposing I now want to do some CDK development, but I want this development to be done via my other account, my CDK user account. How do I tell the CDK framework it should be using these set of credentials when it's doing its communication as opposed to the default ones? And the answer to that is you add on this profile option to the actual command. So it's CDK minus manage profile, whatever the profile name is. In my case, in the example here, would be CDK user, and then the rest is as before. You do that for all CDK commands, not just the bootstrapping commands. So if we were doing a CDK deploy, it would be CDK minus manage profile, CDK user, deploy, etc., etc. Now, having said all of that, can I just summarize what I'm trying to get across here? What I'm trying to get across is, number one, you should log into your AWS account, your personal AWS account, as the root user, which brings you to here. Okay, you've logged in as root user. You should go away and create an IAM user for your account, following the procedure that I showed you there a moment ago. Having created that user, you should generate access key credentials for that user. So a user now has two sets of credentials. They have their access key credentials, which they use if they want to communicate with the AWS cloud, either from using the AWS CLI or using the CDK framework from the command line. But also, you want to be able to log in to the management console, the browser, in other words. You want to be able to log in as that IAM user. And for that, you need your password credentials. And there's no place to actually store the password locally on your machine, other than whatever way you store passwords, or you hold on to passwords. So we've created the IAM user. We've generated a password for that user and a set of access key credentials. With those access key credentials, you then need to go back to your local machine. You need to go to the home folder of your machine, which in my case was, is here. You need to find a subfolder within the home folder called .aws. And inside that subfolder, there are two files called config and credentials. In the credentials one is where you put the access key stuff that I was talking about. That stuff. Now, in your case, if you have a file called, well, you will have a file called credentials. If there's nothing in it, which means you haven't been using the AWS CLI at all, and you certainly haven't been using the CDK framework, then you have two options. If there's nothing in it, you can actually set up a default profile and make the credentials associated with that default profile the credentials of the IAM user, CDK user that you just created. Or if there is already a default profile in there and you want to hold on to that default profile, which is probably the case maybe for the people doing the cloud stream, then in that case, you've got to set up a second profile, which is this one here, for this IAM user. Because for the people that are doing the cloud stream, they will be using their own personal AWS account for this module, distributed systems, but they'll be using the Academy account for doing the other cloud stream modules that you're studying. So those people will definitely need two profiles, whereas everybody else really only needs one profile. And if it is only one profile, the only profile that you will be using is the one linked to the IAM user that you've just created. So you can call that profile default, or you can call it something specific. It's up to you, really. Now, the last remaining piece of the jigsaw is, it's only a small part really, but let's see where have I got it. Yeah, the second file here, config. In that file, if I open up my fake config file, don't have the fake config. Oh, there it is there. The config file and the credential files both have profiles within them. The credentials one is what I was showing you, and that's where you put your access keys associated with a particular profile. For the config, what you've got to do is specify what is the default region associated with a particular profile. So in my case, and in your case, it's going to be EU West 1. Now, because I've got two profiles set up in my credentials, let's just leave that open. Because I've set up a second profile here, what I'm going to do is copy that. Paste. And, okay, you may be using a different region as your default region for that other profile, but it's unlikely. So I'll just replicate that there. And now I'm good to go. I've got my profile set up and I can use my CDK commands from the command line, and I can either use the default profile or I can use my special profile, and it's up to you as to which you're going to be using. If you're using the default profile, then all your commands will be just CDK space deploy, CDK space destroy, CDK space bootstrap. If it's not the default profile, then you'll be doing CDK space minus manage profile, the profile name, CDK user, and then which particular CDK command you're executing, deploy, destroy, bootstrap, whatever. Yeah, it's pretty, there's a lot going on there just to get ourselves set up, but I think it's probably the trickiest part of the whole lot. So I'm sure you're going to be coming to me in the labs next week looking for some assistance, but rewatch this video and you should really try and step through. And of course, look, if you make a mistake along the way, you can simply go back to log in to the management console using your root account. Let's just go back to it and go to your user and just delete them and start all over again. Easy peasy. Right. I'm going to open the floor for any questions if there are. Some people might have specific questions, or it may be something that you're going to have to just review yourselves before you can get all of this stuff set up. But I'll just pause for a minute or two if people have any questions. No. Okay. I'll leave it at that. So, and I'll talk to you next week.